Hello and welcome to this channel. In today's video I'm going to explain to you the p-value, and this will help you in understanding and also interpreting your p-values in your regression analysis output. So what is a p-value? A p-value is a number that is used to conclude if there is a relationship between an independent variable and a dependent variable. So a p-value will tell if the relationship between the variables is statistically significant or not. It is used to determine if the observed relationship in the sample is also true in the entire population, and it is used alongside the regression coefficient. So when you're interpreting your results, you use the regression coefficient together with the p-value to make your conclusion. So how you interpret your p-value will depend on the significance level that you choose. The most common significance level that is used is 0.05 or a 95% confidence level, or you can also use a 0.01 or a 99% confidence level, or a 0.1, which is also a 90% confidence level. Then when you have a p-value that is less than your significance level, how do you interpret it? A p-value that is less than the significance level can be described as statistically significant. So we can describe the relationship between the variables in your model as statistically significant. And also we can say that the association or the correlation between the independent variable and the dependent variable is statistically significant. Hence, the changes in the dependent variable is associated with the change in the dependent variable even in your entire population. Therefore, the dependent variable has an effect on the dependent variable. So that is how you use a p-value that is less than your significance level to make conclusion. So if the p-value is less than 0.05, for example in this case, then we would say that the relationship between the independent variable and the dependent variable is statistically significant, and hence the changes in the independent variable can be associated with the changes in the dependent variable even in the entire population. Hence, the independent variable has an effect on the dependent variable. However, there are cases where you find that your p-value is greater than the significance level. You get a p-value that is greater than 0.05. So in that case, we interpret that relationship as being statistically insignificant. Therefore, the correlation between the independent variable and the dependent variable is statistically insignificant, and hence the association between the variables at the population level does not exist. So we can conclude that the dependent variable does not have an effect on the dependent variable in the entire population. In this video, I'm going to use the example that we used in the previous video where we are explaining the regression coefficient, and this will help us to interpret the p-value which is used alongside the regression coefficient in making your conclusion about the relationship between the variables that you are modeling. So in this example, we had employee performance as the dependent variable. Then the dependent variables are on-the-job training, we have coaching, a classroom-based training, and workshops. The p-value for the first variable or the first independent variable is 0.002, and 0.002 is less than 0.05. Therefore, we would say that the relationship between on-the-job training and employee performance is statistically significant. That is because our p-value here, which is 0.002, is less than the significance level of 0.05. Therefore, we can interpret this and say that on-the-job training has a positive and statistically significant relationship with employee performance. Hence, we conclude that on-the-job training has a positive and statistically significant effect on employee performance. However, when you go to coaching, we find that the p-value for coaching is 0.063, and 0.063 is greater than 0.05. Therefore, we'll say that coaching does not have a statistically significant relationship, or coaching has a statistically insignificant relationship with employee performance. And therefore, although we found that a change in coaching or a unit change in coaching would lead to a 0.155 change in employee performance, since the p-value is greater than 0.05, therefore we cannot conclude that this relationship is statistically significant, and therefore our conclusion would be that coaching does not have an effect on employee performance at the entire population level. So we will use the same pattern in explaining these values for classroom-based setting and also for workshop, and you find that the value, this p-value for classroom-based training is 0.008, which is less than 0.05. Therefore, we interpret it as we did for on-the-job training, that classroom-based training has a statistically significant relationship with employee performance. And also, if we combine this with the regression coefficient value, we will say that the effect of classroom-based training on employee performance is positive and statistically significant. However, workshop does not have a statistically significant relationship with employee performance, since our p-value here is 0.052, which is greater than 0.05. So therefore, we conclude that workshop does not have an effect on employee performance, and therefore in your final model you would eliminate this variable, that is workshop and also coaching, since they do not have a statistically significant effect on employee performance, and therefore you would remain with on-the-job training and classroom-based training, which have a statistically significant relationship with employee performance. So that is how you interpret your p-value alongside your regression coefficient when you are reporting your results as the output gives you. So that is it for today. If you like this content, please like this video, share it, and do not forget to subscribe so that you are able to get the notification for the videos as we keep posting them.